Welcome back. We're going to do a little something with prefixes today. This is stuff you learned in chems, basically review. Put a little physics twist on it. Get you right. Twist and shout. Okay, here we go. How do we convert using prefixes? You're watching your Phys Teach prefix and unit conversions video. So, we have things that we measure. A physical quantity is anything that can be measured. Physical quantity, length can be measured. Height, mass, volume. All these things can be measured. Brightness. However, some things cannot be easily measured. For example, love and courage. Sure, these are good things. They're real things. We believe in them. We write books about them and watch movies about them and cry and all the rest of that. But you can't really put a scale on it. Oh, his courage was definitely 7 in that movie. It was only 6 in the one before. Things that you can measure and quantify, those are called your physical quantities. All right, let's go over here. So length is one of them. What's the unit for length? Standard SI unit for length is going to be the meter. Length, distance, radius, extent, it's going to be the meter. The symbol is just a lowercase m. Careful, your capitals matter. Mass, standard SI unit is the kilogram. Not the gram, but the kilogram, which we're going to write with a lowercase kg. Time, of course, is the second, which we'll write with an S or SEC. That one kind of gets down to how you write your fives. So put a little asterisk over there, bring us over here. If you're S and you're 5, that's how you write 55. Well, I don't know if you're writing 5 seconds or 55. But if instead your 5 and your S are clearly different, well, then you'll make the decision. This one may be better served with an SEC. This one down here, it's unnecessary. Current, which is one we won't worry about until the spring, that is measured in amperes with a capital A. We won't worry about that one for a while now. Now, actually, there's a note here. When the unit symbol is capitalized, not the unit word, we don't capitalize the words, but when the symbol is capitalized, it's named after someone, named after a physicist, so out of respect. They did something interesting and useful for the world of physics. So over the course of the year, at any point, when you see a capitalized unit like that, it's named after someone, give us a little history lesson. Take a piece of construction paper, draw up something nice, put a picture on there, you can print it, put a couple interesting things, years alive, what they contributed. Doesn't have to be a lot. A few interesting facts, and most of these physicists had very interesting, sometimes painful lives, so get creative with what you find on there. A couple interesting life facts. Okay, let's go over here. Now, there are different ways we have to convert between units. Easy ones are just switching with the prefix. All right, so let's check this out. These are pretty easy. The prefix here is mega or centi or micro or nano. Those are not units by themselves. If somebody says to you mega, that's good, but it doesn't mean anything. Centi. Yeah, great. Centi what? Okay, so the symbol for those. How would you supposed to oh, what's this over here? What? I see those little tabs. Pull me? Pull. Oh, look at, hey! Reference table, where you been? Oh, I didn't see you in a while. You're sleeping over the summer. Well, do you have something that can help us out? Oh, yes, you do. Look at that down here, right here at the bottom. There's a prefixes table. Maybe we can get a zoom-in version. You got a zoom-in version for us? Sure you do. Let's send you back over there. Go on back. There you go. Don't worry, we'll play with you later. Wait. There it is. Look at that. Nice and zoomed in. Here's our buddy. You could help us out. And if you look there, what do you see? Oh, there's mega. Where's mega? Here's mega. Mega, the symbol is capital M. Centi, the symbol is little c. Micro, the symbol is mu. Actually, it's me. So we write it like this. And actually, the way it's properly said is me, so it's like one of those physics jokes. Not mu, it's me, but everybody calls it mu. Anyway, there it is. There's micro. And now scientific notation. The notation is actually given to you. Mega means 10 to the 6th. Centi means 10 to the minus 2. Micro means 10 to the minus 6. How do we know these? Because they're listed right here. Now, we also have nano on here. It's an N. Sure, that one's in here, 10 to the minus 9. So the nice thing is you don't have to memorize. I know you had your King Henry and the rest of that in chem. Here, we got it given to you. So, order of magnitude. And if you remember that, just as a review, that was the approximate strength of these. There's no coefficients here, so these are very easy. Order of magnitude, of course, just 6, -2, -6, -9. So it's just a shorthand way of writing the power of 10. If there were coefficients out in front, we would have to worry about that rounding rule. Standard notation. If you remember, we had a note back when that said when you just have 10 to the, put a 1 point in front of it. Makes your life a little easier. For example, this -9 over here. If you put a 1 point times 10 to the -9, then it's very easy to move your decimal 9 places because it's a negative. Reminder, reminder, because the negative's a small number. So don't worry about left-right rules. It's a small number, so move the decimal to make it smaller. And here you see we actually moved it 3, 6, 9 places. Of course, 10 to the -6, you can take your 1 point and do the same thing. So let's do it down here. So we have a messy and a neat area. 1 point times 10 to the -6. You're going to end up moving this one 1, 2, 3, 4, 5, 6. Put your decimal over here. 0, 0, 0, 0, 0, 1. And if we're going to write this nice and neat, we like to put our lead 0. So 0 point, then go in groups of 3. 0, 0, 0, space, 0, 0, 1. That is micro. That is millionths. Centi, you'll end up doing this. You'll get 0.01. And then mega. You're going to move this one the other way for mega. 6 places in the other direction. They'll give you 1, 0, 0, 0, 0, 0, 0. Good. Okay, let's come down over here. Convert these. Now we have prefix notation. Let's turn it into scientific notation without a prefix. You can go to standard after that if you want, but we've already practiced that. So turn these into scientific. Now this actually is quite simple as well because it's already provided to you. When this says 12 mm, the last letter there is your base unit. So that's a meter, that's a meter, meter, second, and ampere, like we have from that top table. These are the prefixes. So prefix, 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 prefix. You're like, what if, what if? Don't worry, it's easy for you. You'll get used to it very quickly. It's very easy to pick out which is the prefix, which is the base unit. So this is 12. Little m, we look up here in our chart. Little m means milli, 12 millimeters. Milli literally is identical to writing 10 to the -3. So if instead of writing 12 millimeters, you could literally write 12 times 10 to the -3 meters. This is the exact same thing. Over here, instead of writing 6.25 megameters, you can write 6.25. Mega means 10 to the 6. So 6.25 times 10 to the 6th meters. It's the exact same thing. We have not changed anything other than the notation. The meaning, the amount, it's all the same. The magnitude is exactly the same. 120 micro is 120. Micro here is 10 to the -6, so times 10 to the -6 seconds. And finally, 3.1 times centi, c, 10 to the -2, 10 to the -2 ampere. Notice here the things to keep in mind. The base prefix meter is still there. You take away the meter, this number has no meaning. It's no longer a magnitude. Now it's just a value. The meter is still a meter. The second is still a second. The ampere is still an ampere. Those have to be here. Now, this said standard scientific. Now, second mistake you might make, you might automatically switch into like, oh, I want to write this as 1.2 times 10 to the -3 m. Well, that's wrong. It's not 1.2 millimeters. It's 12 millimeters. This is not right. You got to do exactly what it says. In this case, it says 12 millimeters. So the decimal here, though it's not seen, is right there. If you want to put this in standard scientific notation, you have to move this over one spot. You have to make this now 1.2. Well, you can't just change it and everything else stay the same. If you're going to change the coefficient, you have to change the power. Here, we made the coefficient smaller. We turned 12 to 1.2. That's a division by 10. The only way we can keep the entire number the same, the entire magnitude the same, is if we divide the coefficient by 10, we have to then multiply the power by 10 over here, the scientific part of it by 10. So 12 became 1.2. Well, then 10 to the -3 has to become 10 to the -2. The 12 got smaller, the power of 10 got bigger. Those two are the same exact magnitude. 12 millimeters is the same exact thing as 1.2 centimeters, or 10 to the -2 meters. Come over here. This one already is in standard scientific. The 120 is not. So we imagine the decimal right here. We're going to have to move it 1, 2 places. We're going to get this down to 1.2. Now, your chem teacher will tell you that's 2 sig figs, so let's roll with it. 1.2 times 10 to the. Now, you took your 120 and you reduced it not 1 power, but 2 powers of 10. The only way to balance this out is to increase the exponent 2 powers. So -6, -5, -4. Okay. 1.2 times 10 to the minus 4th seconds, and the 3.1 is already in standard scientific. Okay, let's keep going. Cooking with gas. Now, the last piece we'll look at right now is converting into standard notation when you're going between different prefixes. How do we do this? Well, the nicest way to do this is a way you're familiar with. Now, there are multiple ways to do this, more than one way to skin this cat. However, if you are looking to essentially reinforce what you've learned in the past, let's do the way you did in chem. Go through the leader. Everything went through the leader. And that's just fine because it actually works with toodles. Yeah, come on through. Here it is. It works with this. So, hopefully that fits enough we can see what we got to do. Let's go right through it. So there's an example over here with 97.1. M for mega, HZ is the base unit. So this is the prefix, this is the unit. And we're turning this into CHZ. This is the prefix, this is the base unit. If you're ever unsure, you'll see the base unit appears the same on both sides. So this may be written out in words. Turn megahertz into centihertz. 97.1 megahertz, how many centihertz is that? When we say go through the leader, what we mean is take megahertz, turn that into hertz, and then take hertz and turn that into centihertz. So you go through the one that has no prefix. That's probably the simplest and most direct way of connecting to what you did last year. So 97.1 megahertz, you want to convert between megahertz and hertz. So if we look over here, you want to cancel out megahertz. That has to go in the denominator. You want to turn it into hertz. Put that in the numerator. Whoa, what is all this notation? Okay, let's back up a minute. Slow down, Trick Daddy. What you'll see over here is anytime you need to convert from one unit to another. Now, we're not just talking standard to scientific. You're not converting units there. Here, we're actually converting one unit now to a different prefix, a different unit. We'll do the same down below, but not in this video. Okay, what do? Well, you start with what's provided to you. Then, you want to multiply by a fraction. Why? Because you can empower that fraction. You can empower that fraction with units that will cancel in the denominator. In this case, megahertz will cancel with megahertz. And then the new unit you want to turn it into in the numerator. Finally, you need numbers to go in there. It's not 1 to 1. Well, how many? Well, that's where this table comes in. That's where this table comes in up here. Here we go. Notice mega means 10 to the 6th. 1 megahertz is 10 to the 6th hertz. It's just like before. 1 mega, put the unit in there if you want, hertz, is 10 to the 6th hertz. There's nothing written over here because it's a 1. Whenever we have a 1 in front of something, we just ignore it. So 1 megahertz is literally the same thing as 10 to the 6th hertz. Okay, up here, the 1 is next to the mega, so we put a 1. The 10 to the 6th is next to the hertz, so we put a 10 to the 6th. Ah, so now the megahertz cancel, and now we're down to hertz. Cool, but we're not done yet. We're going to get from hertz to centihertz. Multiply by fraction again. Drop that vinculum in there, and now we want to get rid of hertz, put it in the denominator. We want to get into centihertz, put it in the numerator. Now what numbers go with those? Well, just come and look. Oh, here's the centi line. What this is literally saying is 1 centihertz is the exact same thing as 10 to the minus 2 hertz. Just put the units on. That's an equality line right here. They're telling you these two, all three rows actually are exactly the same thing. All three columns, rather, are exactly the same thing. So what number is written next to centihertz is a 1. So you put a 1. You don't get a choice with the conversion factor. It is what it is. What unit is next to the plain old hertz, or what number, rather? It's a 10 to the minus 2, so you put a 10 to the minus 2. Hertz cancel, boom, done. So here's the line actually shown, and you'll get the right answer. So let's try this over here. You may want to pause the video, try it yourself, and then come back, check it out. So we want to turn now from 150 A, whatever that is, ampere, but it doesn't matter. We want to turn that into microampere. So, step 1, fraction, multiply by a fraction. Step 2, units. What unit do you want to get rid of? Ampere. What unit do you want to turn into? Microampere. Step 3, fill in the numbers. You don't get a choice here. The number fill in, that's the beauty of doing it in this order. Once your units are set, the number choice is set. You don't get the oh, I don't know, maybe the 1 goes into no. You go look at the table and it is what it is. Let's clean this up over here. It is what it is. Ampere and microampere, well, that's just micro. You look at it here in your chart. Oh, so just run the numbers in here with it. 1 microampere is the same thing as 10 to the minus 6th amperes. Well, which goes where? The table already shows you. The microampere has a 1 written next to it, so the microampere gets a 1. The ampere has a 10 to the minus 6th next to it, so the ampere gets a 10 to the minus 6th. That's it. Cancel. And look, we're in the unit we want. We're in microamperes. So 150 times 1 divide 10 to the minus 6. Now, if you didn't watch that EE button video, do it already. It makes your life easier. This is basic math over here, and this comes out to 150 times 10 to the positive 6th microampere. Now, wait a minute. What unit goes? The unit you were turning it into, the unit that is left over, that's the unit that we have. Now, I believe this said standard notation. So this is a correct mathematical answer. 150 times 10 to the 6th microamperes, that is a correct answer. But if you want it in standard, we got to imagine that little decimal there, move it twice like we practiced before. 1.50 times. You are literally writing the same magnitude again. So it has to be the same overall strength amount. We made the 150 2 powers of 10 smaller. You better make your exponent represent 2 powers of 10 bigger. So go up to 7/8 microampere. There it is in standard. Okay, let's try another one that's also on the easy side. 5 kilometers into meters. So 5.0 kilometers. Multiply by a fraction. Drop those units in the slot, kilometer, and we want to turn it into meter. What numbers go there? Stop guessing and look at your chart. Kilometers and meters, where is it? Where is it? There's kilo. 1 kilometer is exactly the same thing as 10 to the third meters. Okay, so what number goes next to the meters? The same one that's next to the meters up here, 10 to the third. What number goes next to the kilometers? The same one you see up here, that's a 1. Okay, kilometers cancel. Do your shimmy shimmy, and you end up with 5 times 10 to the third meters. Done. Meter is a unit that's left. Meter is a unit we wanted. Meter is a unit on the answer. All right, let's do a couple that are not harder, but just a little more in the way of steps. 1 TB. It doesn't really matter what TB is, but it's terabyte. So 1 terabyte. Multiply by a fraction. Okay. Get them units in there. We want to get rid of TB. Let's put them down here, terabytes. Now you notice prefix, base unit, prefix, base unit, PU. Okay, so terabytes, you want to go through the liters, so to speak. You want to go through bytes, so terabytes into bytes. Now, I'll show you in the next one. You can do this all kind of in one fell swoop, but for right now, let's do it individually, fraction by fraction. Oh, wait a minute, terabyte. How does that have? Well, let's go up here and see. Check your chart. Bring this chart down here a little bit. Oh, Tara, look at you right up there. That's so nice, hiding out up there. Stop playing. All right, 1 terabyte is exactly the same thing as 10 to the 12th bytes. Well, that tells you what to put where. Tera has a 1 next to it, so we put a 1 next to it. Bytes has 10 to the 12th next to it, so we put a 10 to the 12th next to it. All right, cool. Terabytes canceled. We're in bytes. Now, before you start doing math, notice our goal is gigabytes. So, we're not done. What do? Don't press equals. Put another fraction on there. Stack it on. Fill it up. We want to turn bytes into, now, gigabytes. Well, how do we do that? Well, I don't know. Let's go have a look. Oh, here it is. 1 gigabyte is the same thing as 10 to the ninth bytes. So, who goes with the gigabytes? The 1. Who goes with the bytes? The 10 to the ninth. All right. Cancel out the bytes. Now, are we in the unit we want? Gigabyte, gigabyte? Yes, we are. Run this. Okay? 1 times 10 to the 12th divide 10 to the ninth. It's easy enough math. You're supposed to do that scientific. We practiced that back on W1 too. So 10 to the 12th over 10 to the ninth is 10 to the third. So the answer, 1 times 10 to the third gigabytes. The unit we want. Done. Now, let me pause for a second. I know what some of you were thinking. Hey, I could do this much faster. I could just do this in my head. I could... Listen, this is not the only way to do it. Like I said, one way to skin this cat. However, you better be perfect every time. Not 95% of the time, not 98% of the time, 100% of the time. If you make mistakes on this ever, then let it go. Here's a method where you'll never make a mistake. Learn the method, keep it moving. If you see it clearly and easily and you don't make mistakes, then fine, do it your way. I have no problem with that. Last one, 0.2 centimeters. We want to turn that into kilometers. Okay, multiply by a fraction. We want to get rid of centimeters. And before we go to kilometers, notice, centi, your dividing line, you're just plain old meter. You're 10 to the 0. It's not listed here. So centi, you want to go through the liter, so to speak, which means through the meter in this case. So we got to convert from centimeter to meter. Okay, how do we do that? Not hard. Come check it out. 1 centimeter is exactly equal to 10 to the minus 2 meters. All right, which goes with which? The centi has a 1. Put a 1. The meter has a 10 to the minus 2. Put a 10 to the minus 2. All right. Okay. Now, let's go to the next one. Oh, I was going to show you a quicker way, but that's okay. Same kind of thing. You do the units for both fractions first and then fill in both after. That's all it was. Sorry, I ruined the surprise. Okay, we want to get out of meters, which we're in now. So the centi are gone. We want to get out of meters, and we want to get into kilometers. That's our goal. That's what we want. So how do we do that? Come on over here. 1 kilometer equals 10 to the third meters. Notice, we're saying meters and meters. We're not changing. This is an equality. Each line here is equal. 1 doesn't change anything. This equals this. Within the row, everything's equal. This is equal too. Everything's equal. So if you say, all right, kilowatt meters, well, 10 to the third what meters? You have to stick the same thing on there to keep it equal. All right, what's it say over here? Kilometer has the 1. Boom. Meters has the 10 to the third. Boom. Put them in. Meters will cancel. We're left with kilometers, which is what we want. So we end up with here 0.2 times, this is 10 to the minus 2, divide 10 to the third. So you subtract that power 3. Now we're at 10 to the minus 5. And the unit we want is the unit that's left, kilometers. Good. Now this is not standard, so let's put it standard. In this case, we want to put the decimal immediately to the right of the first non-zero. So you take your 0.2, you want to bring the decimal over here. We want to make this a 2. Times 10 to the, well, all the others we've been reducing the power of that coefficient. Here we're increasing it, that front number. So we went up a power of 10 from 0.2 to 2, we went times 10. Well, to balance this out so that these two are the same magnitude, they have to be. You then have to, you increase the power of 10 up here, you better reduce the power of 10 down here. So it's now 10 to the minus 6th. And let me clean that up. That looks like a negative sign. There we go. That 10 to the negative 5th becomes 10 to the negative 6th kilometers. And there's your standard scientific answer to that. Okay. Now finally, one last tip on this. We'll worry about those harder conversions later on. One last tip on this is this comment, is this reasonable? Is this reasonable? Is it reasonable to say that this 0.2 centimeters gives you whatever number of kilometers? Well, if you think about it, a centimeter is a small thing. You want to turn it into kilometers. Oh, wow. Huh. Kilometers is a big thing. So you have a fraction of a centimeter, you're going to have a tiny, tiny, tiny amount of kilometers, which you see down here we do. It's kind of the is this reasonable? Same thing, number 2. You have 5 kilometers. How many meters does that represent? Well, a kilometer is definitely bigger than a meter. So if you got 5 of them, you're going to have a whole lot of meters. Oh, no surprise down here. We got 5,000. Okay. Hope you had fun.